Thank you all so much for being here. My name is Shreya Ramachandran. I'm the founder of the nonprofit, the Greywater Project. And I'm super excited to welcome all of you to this workshop on greywater and greywater systems. Today we have Dakotah Bertsch here, who's a professional landscape architect who focuses on greywater systems, rainwater, and ecological landscapes. And before we jump into his presentation and the workshop itself, I see a lot of new folks in the audience who haven't been to previous events from the Greywater Project. So I'd love to give our new folks an introduction to what the Greywater Project does. And give me a second here. There we go, just admitting some more people. So the Greywater Project is the nonprofit that I founded to advocate for the safer use of greywater and water conservation. And I primarily focus on education and advocacy. And there's a couple of programs that I wanted to highlight that might be of interest to folks here. And the first is the Earth Day art competition. This is the 4th annual art competition, and it's open to students from around the world. And it's for K-12 students to submit visual art, music, dance, and literature on the theme of Invest in Our Planet. And the selected works, the winners will be displayed at the City of Fremont and Fremont Creates Earth Day on April 22nd. And the first prize winners of each category will be awarded a cash prize of $75. And on the screen are some of the entries from previous year's competitions. And the deadline to submit is April 15th. So if you know some young people in your life that are really interested in visual art, performing art, this is an incredible opportunity for them. In addition, I've developed a curriculum to teach students about greywater and water conservation and the human water cycle, where water comes from, where it goes after we use it. And it's already being implemented in dozens of schools across the US and the world. And I'm currently developing a second version with more resources and translations into other languages. And this work is being supported by National Geographic. So if you're an educator and you're interested in bringing these resources to your classroom, please reach out to me because the Greywater curriculum is entirely free to use. And finally, I've started a policy group to advocate for making greywater systems cheaper, more accessible, and more widespread. So if you're interested in joining as a volunteer, I'd be super excited to have you as part of this team. And if you want to learn more about any of the programs that I've mentioned, you can visit my website here or shoot me a quick email. And you can also stick around until the end of the webinar and ask some questions. So with that little introduction out of the way, I want to turn it over to today's star of the show, Dakotah. Dakotah Bertsch is a licensed landscape architect based in Santa Cruz, California, with a private practice, DBLA, specializing in non-potable water systems and ecological landscapes. He's designed rainwater and greywater systems for residential and commercial projects throughout the San Francisco and Monterey Bay areas, both for irrigation and indoor non-potable uses. So without further ado, take it away.
All right. Hi, everyone. Thank you to the Greywater Project for having me today. I'm looking forward to talking to you about greywater. And I've put together some slides to kind of go over the different kinds of systems that are out there and go into more detail on some of them. So let me just pull up my slide presentation. It's actually, so I need to share screen here.
Oh, and just some quick housekeeping notes. If you're not presenting, please try and keep your audio muted so that we can hear the presenter. And if you have questions throughout the call, put them in the chat and we'll have time to do a little Q&A towards the end of the presentation.
So yeah, as you mentioned, I'm a licensed landscape architect with my own business, DBLA. Over the last 12 years or so, I've developed kind of a niche doing rainwater and greywater systems. And I've done dozens of systems throughout the San Francisco and Monterey Bay areas over the last years. Just as an introduction, a lot of people don't know what a landscape architect is. And in my job, I do design work and consultation, everything from schematic and conceptual design through detailed plans and specifications, researching projects. In addition to rainwater and greywater, I do irrigation and planting plans and all kinds of site plans and stuff like that. And so the product of my work is drawings, and I also help with permitting. Having a license from the state and the stamp gives me some weight with jurisdictions to approve these plans, and basically I take on some liability if they don't work. I also help with contract administration, ensuring that projects are installed successfully by contractors. However, I'm not a landscape contractor myself, and I don't build the projects. So what is greywater? This is a quote from Art Ludwig, who's kind of the pioneer of greywater in California, based down in Santa Barbara. And he says it's any wastewater that's not water from toilets that can be used for landscape irrigation. And there's some gray area, you might say, like kitchen sink water and laundry water that's used to wash diapers might be considered dark gray water or undesirable water for a gray water system. But basically it's the wastewater we produce that's only lightly used, that is not so contaminated that it can't be broken down easily by the living biotic activity in the soils and plants. And so why should we use greywater? I just chose this image because it shows an example of the extent we go to create a vast network of infrastructure to supply clean water to all of us. And so there's a lot of embedded energy in that system. And as we know, even though this is a wet year we're having here this year, we are in a longer drought cycle. And the nature of living in a Mediterranean climate is that we have long dry seasons where we don't have rainwater. So by using greywater, we're less reliant on that freshwater infrastructure. So there's some independence in that. It also, greywater can also, reduce strain on a failing septic system or treatment plant by diverting some of that less contaminated water to the landscape. This is according to Art Ludwig. It actually produces better treatment because the biotic activity in the topsoil is more effective than a wastewater treatment plant at breaking that down. There's less energy and chemical use, promotes groundwater recharge, and promotes plant growth. The plants actually benefit from the nutrients in greywater, including some of the soaps that are in there, as well as our dead skin cells and whatnot that washes off into the greywater. So that's reclamation of otherwise wasted nutrients, and more connection to natural cycles and to the landscape outside your house. So how much greywater can you harvest? There are a number of different ways to figure that out, and it really varies person to person and household to household depending on your water use habits. Just as a estimation, you could say that average American produces 20 to 40 gallons per day. The California Plumbing Code has numbers in there for calculations, and I would say that these are on the high side, conservative estimates from a plumbing standpoint, because they want you to create a system that can handle kind of the maximum amount of gray water and not be undersized. So they come up with 25 gallons per day per person for showers, baths, and bathroom sinks, and 15 gallons per day per person from laundry, totaling 40 gallons per day per person. So that's one method, and another method is to calculate based on your average uses, and you can do that by keeping track of, how many gallons, how many loads of laundry you do per week, how many gallons your particular machine uses per load, and adding that up for laundry. And then for showers, how many showers do you take a week, how many, and then what your particular shower head puts out in terms of gallons per minute, and how long your showers are for each person in the household. Similar with baths and sinks. So that's one way. You can also compare that to your water bills. If you look at your water bills, they're probably in cubic feet or centicubic feet, 100 cubic feet, which is like 750 gallons. But that's going to be higher in the summer because that's when you're using irrigation most likely. So you want to look at winter water bill, sorry, and about 75% of that is going to be gray water that you can harvest. So just as a rough approximation, let's say that each person produces 30 gallons per day times 365 days per year is about 11,000 gallons per year. So if you have a household of 4, you might get, and you subtract some for days of the year that you're not home, you might add up to around 40,000 gallons. However, you also have to consider that you're not going to be using gray water all year because of winter rainfall. So gray water is primarily used for irrigation in the summer. So the amount of water that you offset, potable water that you offset, might be half that, 20,000 gallons. Oh, and just for comparison, this is a 30,000 gallon rainwater tank. So just to show that gray water adds up to a very significant amount of water when it adds up every day, throughout the year. You wouldn't store gray water in a tank like that. You can't store it long term because it goes septic pretty quickly with that high nutrient load. Unlike rainwater, which is relatively clean and can be kept in large tanks. So that's just a size comparison. So how to use gray water? Here are some basic rules. You don't want to contaminate gray water with black water. So you don't want black water going into your landscape. And black water is, water from toilets. So wherever there's a connection, for example, in a branch drain system, if you have a diverter valve, or if you have a surge tank that overflows to the sewer system, you need to have a backflow valve, or also known as a one-way check valve, so that the black water cannot back up into the gray water system. Similarly, you don't want to have a direct cross connection between gray water and drinking water, so that you don't end up drinking gray water or contaminating domestic main line with gray water. So if there's a backup to a greywater surge tank. It needs to have an air gap so that there's no chance that greywater will back up into the potable water system. You can't store greywater for more than 24 to 48 hours. A lot of resources say 24, but I've found that others say up to 48 hours. Essentially, when you start storing it long term, as I mentioned before, the anaerobic bacteria get active and it starts getting really stinky, and quickly turns from gray water into black water. So you kind of want to use it as it's produced in a short time span. Don't distribute it during the rain, or sometimes shut it off during the rainy season, or allow it to run off site. You don't want gray water mixing with rainwater runoff and ending up in streams and rivers or ponds and impacting aquatic life. Avoid human contact. You don't really want to touch it or drink it. So no pooling or ponding or puddling or open containers. And we always apply gray water under mulch so that there's no chance of contact. And we apply gray water to the upper biotic layer of soil because that's the most biologically active with microbes and roots, so that they can break down those extra nutrients quickly. If you were to send gray water deep underground into more mineral layers of soil, it wouldn't break down and it would potentially contaminate underground aquifers. And finally, don't use harsh chemicals in a gray water system. The plants like the extra nutrients from soap and skin, etc., but they don't like bleach or other harsh chemicals. So this is an illustration of that. We want to apply gray water at the drip line of the tree canopy in mulch basins. So here you see a mulch basin which has a protected outlet, which basically lets gray water flow unrestricted into the surrounding mulch and infiltrate quickly. You see that in profile view. This is a mulch basin, basically a pocket in the soil filled with mulch that can break down and get replaced periodically. And then the gray water filters through the mulch and into the soil, and the plants take it up. So there are a number of different types of gray water systems. This illustration by the Greywater Project is very nice, and it shows a couple different types of systems going on here. We have one system coming out of the washing machine. This is a laundry to landscape system, going directly from the washing machine into the landscape, and it notes that no permit is required for a laundry to landscape system. And then here we have like a branch drain system or a pump system, collecting from multiple other fixtures, including baths and showers, and that does require a permit. And you don't want to collect from, you can, it's not illegal to collect from kitchen sinks. However, I avoid it because there's a high nutrient content with all of that food waste that tends to clog up a gray water system. So just a brief overview of different types of systems. There's laundry to landscape, branch drain, and pump systems. And each one has different levels of complexity depending on what type of system and how many zones or what type of irrigation you want to use. And so I'll go into more detail into each of these kinds of systems. So first, let's talk about laundry to landscape, or L2L. So as I mentioned, laundry to landscape is what it says. It takes water from the washing machine and puts it directly into the landscape using the pump that's built into the washing machine. And it distributes it to mulch basins at the base of plants. In California, you don't need a building permit for laundry to landscape systems. So they're a type of system that can be installed by homeowners for just a few $100s in parts. As a landscape architect, therefore, it's not usually a kind of system that I get involved with, because it would be too much of an extra cost to, do full designs for laundry to landscape system. It's usually done by homeowners or contractors. And you're kind of limited as to how many mulch basins you can reach, depending on what kind of washing machine you have. High efficiency machines use less water, and so when they pump out that water, they're not able to fill as much pipe and get that water to come out at as many locations. So with an old style top loading machine, you might be able to get up to 20 mulch basins. With a more efficient machine, you might be able to get water up to 8 locations. And you can go about 50 feet away on flat ground. And when you're designing your laundry to landscape system, you want to be careful that you don't overburden your washing machine pump. You don't want to wear it out too quickly or avoid your washing machine warranty or anything like that. So generally you want to avoid pumping uphill if you can, and you want to avoid long pipe runs. Also, you don't want to restrict the flow of the water, putting back pressure on the washing machine pump. So, you wouldn't want to have too many flow restricting valves at the outlets. And you also should always keep at least one pipe end fully open so that the washing machine has unrestricted flow. Here's a nice illustration of that from the greywater project, showing water coming out from the washing machine, and shows some of the typical components. As the water comes out from the washing machine, there's a 3-way valve so that you can select whether the water goes to the greywater system or to the sewer. For example, you would send washing machine water to the sewer if the greywater system is having a problem and needs to be maintained, or if you're using bleach or harsh chemicals or anything like that. This also shows something up here, which is called an AAV, an air admittance valve. My understanding is that allows air into the system when it's not pressurized, so that the pipes can drain fully into the landscape and you don't have greywater sitting stagnant in there. And then it shows piping system to mulch basins with, you would have basically just open pipe ends inside these boxes in the mulch. Here's another illustration, shows a little more detail. So again, you have the washing machine 3-way valve, the air admittance valve, show a network of emitters in mulch basins at the bases of plants. And here you can see there's only 2 flow restricting valves on this system. I guess probably if these 2 valves weren't there, most of the water would come out of into these 2 mulch basins because they're the closest to the source. So closing that valve a little bit forces water to continue further into the pipe so that it can reach more mulch basins. However, down here at the bottom, you can see there's one fully open pipe so that the overall flow from the washing machine is not restricted. Here are some of the typical components in real life. It shows a mulch basin, basically an open-ended pipe coming into a irrigation valve box with a lid, so that there's no chance of somebody touching it. However, you can open it easily and inspect it for clogs and make sure it's flowing correctly. Air admittance valve, 3-way valve, anti-siphon valve. And I don't think an anti-siphon valve is always required for this type of system. However, if you were for some reason pumping the water uphill, you would want an anti-siphon valve to make sure that the water didn't flow back into the washing machine. Here are some more resources for these systems. The Greywater project website has a lot of good information and tutorials, and I saw a nice video there as well. So check that out. And a couple of great books, Greywater Green Landscape by Laura Allen, and Create an Oasis with Greywater by Art Ludwig. And then also, oftentimes, your local jurisdiction and water district will have resources for you. They might even have rebates to offset the cost of buying these parts. So the next type of system I'm going to talk about is a branch drain system, which is kind of a step up from laundry to landscape, because it can collect from multiple different types of fixtures, including showers and baths, which in my opinion are the primo source of greywater, because showers and baths produce a lot of water that's very dilute. For the amount of water that we use in our showers and baths, there's a very small amount of soap and hair and skin and other contamination. It's relatively clean gray water, and it's usually the best source as far as quantity. So a branch drain system only uses gravity to distribute the water. There's no pump, there's no washing machine pump. So it's a low pressure system with larger pipes, and those pipes need to slope downhill in order to get water from point A to point B and C and D. And in order to get that water to different mulch basins, it requires the use of flow splitters, which are like T's that are designed to split the flow evenly in two directions. And depending on the types of fixtures and the number of fixtures you're connected to, you might be able to split, up to 16 or 32 outlets. Branch drain system does require altering the plumbing, usually under the house in the crawl space or in the basement or mechanical room or what have you. And because you're altering the house plumbing, it does require a building permit in California. And so the way it typically works is, you're taking that water from the those fixtures and sending it into one gray water pipe with a diverter valve in an accessible location. That's a three-way valve that can divert the water either to sewer or to the gray water system before it hits those flow splitters and starts sending it to different points in the landscape. Here's a simplified illustration of that. So this is, water piping under the house coming out to a diverter valve, which goes to the sewer. You have a check valve to prevent sewer backup into the gray water system. And so that first gray water pipe has 100% flow before the first flow splitter, which splits it evenly into two streams, each with 50% of the amount of water, and then you split it again, each one again. So each of those four streams has a quarter of the amount of water. So as I mentioned before, you can get up to maybe 16 or 32, depending on the fixtures you're connected to and how much water they produce or you produce. It's a picture of some of that plumbing under the house. So you can see this is the old sewer line here, and they've disconnected from different fixtures, sink, bathtub, showers. They're all converging into one gray water line, which then goes out to the three-way diverter valve. So here's an image of a diverter valve in the field. I mean the flow splitter. Sorry, this is the diverter valve down here at the bottom. There's presumably the gray water at the center of the valve that can either go out to gray water or back to sewer. And then there's a flow splitter, which is a specialized T valve. And what they usually do in branch drain gray water systems is drill a hole on the top of the valve and put a plug in there so that if there's a clog, you can go take that plug off and inspect it or flush it out. And then this shows, a flow splitter. It's got a piece of rock or concrete or something underneath it so that it's perfectly level. You use a level to make sure it's level so that water flows equally in both directions. And it's in a irrigation valve box that's going to have a cover at grade so that in the future you can take that off and inspect it. Now, one of the things about branch drain systems is it can be tricky to reach a lot of plants in the yard, and it can be a difficult system for a retrofit because it kind of requires tearing up a lot of the yard in a lot of cases if you want to reach a lot of plants. So this kind of shows that, this network of pipes, it splits and then splits again. So we've got straight runs of large diameter pipe. So it can be a little invasive, and you're kind of limited as far as the number of mulch basins that you end up distributing to. So the third and last type of system I want to talk about is pumped systems, and this is what I'm most familiar with as a landscape architect. This is what I design most of the time. Although that's not to say it's the best type of system. It's just typically what my clients prefer, mostly because it's adaptable to their existing landscape, and the water can be distributed throughout their landscape to reach their existing plants. So it's similar type of collection system to a branch drain system. You're going under the house and redirecting that plumbing. The difference is after the diverter valve, the gray water is going into a surge tank with a pump in it, which pumps it out to irrigation. It's not a large storage tank, unlike a rainwater system. It's sized to handle basically the amount of water that you would produce in a day, maybe a little more. But it's just a surge tank so that you can have enough water to pump out, essentially. So there's different levels of complexity in pump systems, from very simple system that's just like a sump pump that goes to a laundry to landscape like distribution system. The next level up would be like using an indexing valve, which can send water to different zones. Each time the pump turns on, the valve rotates and sends it to a new irrigation zone, up to maybe 8 zones. And then more complex systems use a filter after the pump, so that the water can be used in drip emitters. So for drip emitters, you need to filter down to maybe 100, 150 microns. And so those filters will collect, the debris that goes into the gray water system, and they need to be maintained or backflushed and cleaned off. So that's a point of maintenance, a level of complexity. However, it creates a system that's more versatile. Next step up would be having an automated backup supply. So having rainwater or potable water back up the surge tank. When there's no gray water and the irrigation system wants to use water, then it refills it with backup water. So in that type of system, you basically have a constant pressure system or on demand. So it can function just like any other irrigation system. And you can control the irrigation with the use of a standard irrigation controller. So overall, pump systems are more expensive, more complex. However, the benefit is you can use a regular drip irrigation system. And you can have as many zones as needed, any kind of landscape design, and it can be fully automated. Here's a simple illustration of a kind of pump system where we have water draining from a tub to a three-way valve before it goes into a surge tank. Surge tank has a simple screen inlet filter. I usually use like a sock filter, maybe 300 mesh or something like that. And then so the gray water can also be diverted to sewer or septic. The surge tank also has an overflow, gravity overflow to sewer or septic in case the pump fails or anything. There's a pump, submersible pump inside the surge tank with float switches, float sensors, so that the pump doesn't, dry run and break down because there's no gray water. And then it goes out to filtration. And the filtration can have additional three-way valves and connections for back flushing with potable or rainwater. This is a detailed drawing from one of my designs. In this case, it's an above ground surge tank in a garage under the house. So we have gray water coming down from the house to that three-way diverter valve and into the tank with the sock filter. We've got that pump with float switches, float sensors. It goes out to the filtration device, which has additional three-way valves for back flushing. We also have an overflow and bypass back to the sewer. I just pulled up some random illustrations of pump systems that I saw online that I just wanted to talk about, misconceptions. This one shows separate, it's obviously an oversimplified drawing, but it shows separate lines going to the surge tank, which is possible, but you would want to combine them so that you could have a single accessible diverter valve going back to the sewer. The surge tank would also need to have an overflow back to the sewer. And you would never use gray water for spray irrigation. It needs to be applied into the mulch or soil subsurface. In this illustration, similar to the last one, the surge tank, well, I don't know, maybe that's a treatment system. That's just not shown, but anyway, it doesn't show any kind of overflow or bypass to the sewer. And then in this case, they're showing it going into a toilet, which is something that I do with rainwater, which is a higher quality water source, but putting gray water indoors where it can into a toilet bowl where you can come into contact with it would not be permissible under the California Plumbing Code. So this would be a no-no in California, at least. Here's a nice image of a greywater surge tank system installed. We've got the greywater line coming into the three-way valve. This diverter valve has an actuator on it so that it's electrified and you can operate it from a switch in the house, presumably. That would be useful when the surge tank or diverter valve needs to be in an accessible location, such as under the house. And then it goes into the surge tank. Surge tank has an overflow with a backwater valve to prevent sewage backing up into the surge tank. Surge tank has a pump with a float sensor with the line out to landscape irrigation. This is me crawling under a house, which to get the lay of the land and figure out where the plumbing is coming from the fixtures. Sometimes I have to run water into the fixtures and listen to figure out exactly which pipe is coming from where, so that when I do my design drawings, I can show accurately where we're collecting water from. And this is a site visit during the installation of a greywater system in, this one is in Belmont. I believe it was the first permitted system in Belmont. And you can see the old cast iron sewer pipe and the new greywater pipe coming. This is where it comes back into. Here's the overflow from the surge tank meeting up with that greywater. This would be from the diverter valve. And this is going back into the sewer with a check valve. And this is the partially embedded greywater surge tank. There's another system in, this one's in Saratoga, I believe, coming out under the house onto this slope. So this is another kind of mostly embedded greywater surge tank. This one is fiberglass. The last one was ribbed PVC pipe. And so this uses basically like a pool style filter, which can be back flushed. So it has a line out to irrigation, as well as a line back to the sewer where the back flush water goes. More images of looking into surge tanks for pumped systems. So on the right here, you can see, typically often coming out from under a house, it's necessary to core drill holes through the footing or foundation to get that greywater out. You need to keep the greywater pipe as high as possible so that it can go back in and reconnect with the existing sewer pipe. So that's why we come out as high as possible under the house and then core drill through the concrete. Comes out, hits that three-way diverter valve, which can go either back to sewer via the one-way check valve or into the surge tank. This shows a surge tank with a one-way check valve in it for the overflow. This is the greywater coming in with a mesh sock pre-filter, which catches hair and lint and stuff like that. And then down here in the water, there's a submersible pump that pumps out through this line out to irrigation. So the filtration manifolds can be pretty complex. This is one of the higher end, more complex systems from Water Sprout. So this is actually a combined rainwater and greywater manifold. So we have pipes coming in from greywater surge tank, the rainwater tank, as well as potable backup water, and a lot of automatic solenoid valves to determine which water is going out based on availability, which the controller determines based on the float sensors in those respective tanks. And then it also monitors water use from each source. And it also has filters. This type of system uses simple irrigation style screen filters. Even for greywater, it just back flushes. It just flushes those filters very frequently to make sure that it doesn't, the gunk doesn't build up on the filter. It has an automatic flush valve on the outlet of the filter. There's another, more complicated system, also using greywater and rainwater. In this case, this is in the Los Altos Hills. This is in the mechanical room under the house. You can see down here, this is during construction. You can look through that door and see a glimpse of the rainwater tank. So this is the above ground greywater surge tank right here on the left. with the larger rainwater storage tank in the back. And in this case, greywater is used for irrigation, while rainwater is used indoor for toilet flushing and laundry washing. And since it's going indoors, that's why we have slightly more filtration here, including a carbon filter and a UV light. That's rainwater. I wouldn't do that for greywater. There's a number of different companies selling pumped system kits and manifolds. These are a few of them. I showed you some from Water Sprout, and ReWater uses pull filter style filters like the one I showed you before. ReWater has been around probably the longest. This says since 1990, so they've been doing this for over 30 years, and they're very experienced. They're down in Southern California. Water Sprouts in the Bay Area. Not as familiar with these other ones. And this is just to go over some, the process. My scope, I would consult with you and kind of help determine the type of system based on your site and watering needs and your budget and what makes most sense. Then design the system, including plans, details, specifications, and whatever is needed. Use those to apply for permits as required. As I mentioned, you don't need a permit for a laundry to landscape system. However, it is needed for a branch drain or pump system. And then use those plans to get installation bids from contractors who would install the system. And then at the end, you would get that signed off and commission or start up the system. I want to talk a little bit about rainwater versus rainwater, or with rainwater, because they can work together in different ways. But they're sometimes confused, but they have very different qualities. So we've talked a lot about what greywater is. Rainwater is considered, for a rainwater system, typically rainwater is water that runs off your roof from a rain event. So greywater is relatively dirty with skin and hair and soap and all that stuff, while rainwater is relatively clean, falling fresh from the sky. So for that reason, rainwater can be used in more ways. It can be used for spray irrigation, and it can be used indoors for flushing toilets and washing laundry, while greywater should only be used for subsurface irrigation. It's not to say you can't use it for more things. It is possible to treat greywater to a level where it can be used for indoor non-potable, but that's essentially a recycled water system. And that's usually only feasible on a larger scale, such as like a municipal, sewage treatment plant. They take black water and often treat it to the level where it can be considered recycled and used in golf courses and irrigation and stuff like that. But on a small scale for a homeowner, it's not feasible to treat greywater to that level. So greywater is produced year-round on a daily basis, including during the summer when you need it for irrigation, while rainwater only falls in the winter, and so you need to catch it and store it in large storage tanks, that can hold it until summer when you need to use it. Whereas for greywater, you only need a small surge tank for what you will produce in 24 to 48 hours. So greywater must be used immediately before it turns septic, whereas rainwater, because it's clean, can be stored long-term. Greywater tends to be slightly alkaline because of the soaps. However, rainwater tends to be slightly acidic because of the carbonic acid in the atmosphere, like acid rain. So in that sense, they kind of balance each other out. If you're using an irrigation system with greywater as the primary water source, that uses rainwater as backup. The rainwater will flush the gray water out and also balance it out on a pH level. So just for size and cost comparison, this is a greywater surge tank getting delivered to a site in Los Gatos. And so that's maybe 200 gallons or less. Whereas these are common rainwater storage tanks. This is, maybe a 1,200 or 1,500 above ground poly rainwater tank. This is like a 20,000 gallon underground fiberglass storage, rainwater storage tank. This is a 100,000 gallon above ground rainwater storage tank. So for rainwater, typically the limiting factors of a rainwater system are available space and cost, because these tanks are a lot more expensive. Whereas that's not as much of an issue for a greywater system. However, we went over some of those numbers before, and you can get tens of thousands of gallons from a greywater system with a small surge tank without having to put in tens of thousands of gallons of storage. This is an interesting graph I made using actual water use data from a project. This is actually that project we saw before in Los Altos Hills with the gray water for irrigation and rainwater for indoor non-potable. And we've got gray water in light pink and rainwater in magenta. And I just think it's interesting to see how the gray water is used in the summer when irrigation is happening, kind of drops down to zero in the winter months, picks up here in April, May, June, July, August through September, while rainwater is available and used indoors during the winter months when the rain is falling, and then it quickly tapers off in the summer because the tank empties out. So in that sense, they complement each other in terms of offsetting potable water use and using non-potable water. Rainwater use indoors can be, used more during the winter months, while gray water can be used more during the summer months for irrigation. And so we have come to the end of my show. Thank you very much for listening. I also wanted to mention, it says ROI down here. These systems, gray water systems, especially pump systems, can be relatively expensive for the homeowner and difficult to pencil out on an ROI basis economically, because as a society, we've invested so much in that these elaborate potable water systems with a lot of embedded energy, but we keep those water prices very low. So in my opinion, potable water prices are kind of artificially low. So it's more difficult for these non-potable water systems to pencil out. However, as one of my mentors likes to say, you get a return on innovation, a return on independence by having this type of system that you can enjoy reducing your waste and using that water beneficially in your own landscape. So that's all. I guess if we have time for questions, I'd be happy to answer any.
Amazing. Thank you so much for going through all of those various types of systems, giving us an introduction at the beginning about what gray water is, how it can be used, why to use it, and then going through the types of systems and the methods for using them for a homeowner. So if anyone has questions, put them in the chat or feel free to unmute yourself. We have a couple of minutes. I think we can run a little bit over to answer some folks' questions. And we have one from Holly who asks, anything for the non-formal system homeowners, like capturing kitchen / bathtubs, sink, and a bucket. So non-formal gray water systems, I believe is the question.
Yeah, I mean, I think that's great. I mean, especially if you're a renter and you can't, put holes in the walls. Capturing water in a bucket or bucketing out your bathtub is a great idea. I think it's, if you have a mulched, you could set up mulch basins around your fruit trees where you could just dump that water and let it soak into the ground. I don't really have anything other than that, as it's not really a built system, but I think that's a great solution in some cases where a built system is not feasible.
We have a couple, thank you for that. We'll take the question from Tim and then go to the other 2 questions that are in the chat.
Thanks. After the gray water system, when you're pumping onto, it sounds like you're using irrigation mostly for trees and shrubs. There are these underground or just below ground soaker hoses and above versus below ground. Can you use any of these with this system? And there's several different types. It's hard to find people that really have experience for it. And what do you do about clogging for some of those things?
Yeah, it's a good question. I mean, people have different opinions about that. And different companies who produce those pump systems will have different recommendations depending on their system and the level of filtration. So personally, I would stay away from underground soaker hoses, just because of the difficulty of digging them up and maintaining them in the case that they do clog down the line. Some of the systems that I use are filtered to the level where they can be used in typical drip irrigation. Some of the systems recommend using like higher flow emitters, which reduces clogging. And like ReWater, for example, they have their own special emitters, which are basically the like open end 1/4-inch tubing that has a plastic cone on the end of it that creates a void space for the water to flow into to prevent clogging. But typically, I use like inline drip emitter tubing, where it's not. I don't know if that's what you meant by soaker hose, but it's poly tubing that has built-in internal emitters. And I would recommend putting that under mulch, but on the surface of the soil so that it's right there, going onto the most biotic layer of the soil, but is protected by mulch so that it's not, going to be a health hazard.
Can you use that type for lawns, just on the surface?
Yeah, you can go subsurface under a lawn with inline drip emitter tubing. In that case, I'd probably recommend using like a type of tubing that's designed for lower quality water. I'm forgetting the names, maybe GeoFlow or some of these other tubing, so that there's a lower, and a more robust level of filtration, because you don't want to have to dig that up down the line. You'd also want to have flush valves at different points at the end of the line of tubing so that you can periodically flush out that line and any accumulated gunk in there. But yeah, you can use gray water under a lawn, and actually a lawn's a pretty good place to use gray water in that way if you have a pump system, because they require more water on a more regular basis than drought tolerant or native plants. A lot of people ask about, can you use gray water on native plants? And you can, but it's tricky sometimes because native plants are adapted to be drought tolerant and to have long dry periods. So if you're going to use greywater for native, California native plants like ceanothus or manzanita or something like that, you'd want to set up your system with enough different zones that, at least 7 zones that you water each one once a week, so that that particular plant is not getting watered every time you use greywater. It's only getting watered once a week. It soaks in, it dries out, and then you water it again a week later.
Awesome, thank you for that question. So we'll take the questions from Alan, Holly, and then Aparna, and then the question from Bradley. So in the chat, Alan's asking, can greywater be used for apricot, nectarine, pear, mango, or banana trees? So
Yeah,
fruit tree lover.
yeah, absolutely. Fruit trees love greywater, and I think that's an excellent use of it. The extra nutrients from the soaps, as well as skin cells and all that stuff that washes down a greywater system, is like fertilizer for fruit trees. And there's no, the only, for edible crops, you don't want to use greywater on like root crops, things, where you might harvest it and eat something that had direct contact with the greywater. However, for a fruit tree, the greywater is getting broken down in the soil and by the roots and in the plant. And so the fruit itself is not going to be contaminated at all.
Awesome, thank you. And Holly asks, can you describe the mulch basins in more detail?
Well, that's not my forte. As I mentioned, I have really only done pumped systems into drip irrigation, which doesn't require mulch basins. But essentially, with a mulch basin, you're digging a pit, or it can be I think the Greywater project probably has more experience digging mulch basins, but you're digging around a plant. Could be like a kind of like a donut shape surrounding the drip line of the plant, or a trench, along a row of plants. And then you take that soil that you're digging out and you can berm it up around the sides to deepen the basin. And you're filling that basin with mulch, which creates a void space for the greywater to spread and infiltrate into the soil throughout the basin. And it also creates a matrix for microbes and fungi and all those things that break down the extra nutrients in the greywater. And so eventually that mulch is going to break down, and you just have to dig it out and use it as like compost around your plants and put in fresh mulch.
Yes, exactly. That is pretty much how I would describe mulch basins as well. It's essentially you're digging around the base of the tree or the plant that you want to irrigate, and you can use like a variety of like mulch materials to fill in that mulch basin, including just like wood clippings and compost and other things like that. So it's fairly simple, and it's a way for the water to seep into the surrounding area once you put in that emitter box if you're doing a laundry to landscape system. So exactly right, and hopefully that provides some extra clarity. And moving right along, Aparna is asking, can these systems be installed in homes with slab foundations?
That can be tricky. Oftentimes the answer is no. Just, it's for example, if the shower drain pipe that you want to use for greywater connects with the sewer main from the toilet under the slab, then there's no way of diverting that greywater without excavating and destroying the slab. So if you're doing a remodel or something like that, then you can plan ahead and have those greywater pipes connect outside of the slab foundation so that they can be tapped into in the future. But if the greywater fixture drain pipes connect with the sewer main under the slab, sometimes you can't do this type of system. However, you can always do a laundry to landscape, because that gets pumped up above the slab.
Thank you.
Or, for example, you could also like elevate your bathtub and have the drain from the bathtub go out the wall above the slab.
Right, okay. Thank you.
Awesome. And then we can take 2 more questions before we are truly out of time. So we'll take Bradley's and then the question about golf courses that's in the chat.
Hi, yes, I'm actually with Hydroloop. You mentioned that the greywater systems, shouldn't be routed to stuff like toilets and such, water closets, unless they're filtered. Would that be to the NSF standard required by state code, or is there something else?
Right, yeah, that would be to the NSF standard.
Okay, if it's like a patented technology, of course.
Well, no, I mean, the NSF standard is just a standard of water quality. And different, there are companies that have patented systems to treat greywater to that level.
Okay, I'm just.
I think, yeah, it's doable. It's just, it tends to be more expensive, and also with treating water to that level, my understanding is that there are ongoing testing requirements. It's basically considered an on-site wastewater treatment plant. And so for a typical homeowner, that would be a little onerous to have that ongoing testing and treatment to that level.
For non-potable?
Right, yeah, for greywater to non-potable.
Okay, is that in the code, in the state code, or is that somewhere else, like in a health department code?
I believe that's part of the NSF standard.
Well, the NSF, yeah, NSF is administered as a standard, but certain states can require you to do testing. As far as I know, California as a state doesn't require it. Certain counties and cities might require it, but the only states nearby that would require it, I know Arizona does it for if you do toilets, and then same with Oregon. But I don't know anything as far. That's why I'm just curious if you know something that I don't. That's all. So.
Yeah, I'm just going off of what I've heard from other people who are more expert than I am, but I don't have specific knowledge of that.
Okay. That's all.
Thank you for that question. And last 2, we have a question about the types of water that's generally used in golf courses. Or I guess to paraphrase from what's in the chat, like how greywater and rainwater systems can be used in golf courses.
So I think that's referring to recycled water. So there's a difference between recycled water and greywater and rainwater. Although they all use purple pipes, which is why this presentation has a purple theme. The recycled water that's often used in golf courses is coming from the municipal wastewater treatment plant, where they're taking black water and treating it to a level where it's considered safe enough to use for irrigation. And golf courses are convenient places for them to send a lot of that water, because they're putting in new separate distribution plumbing from the treatment plant to the golf course or wherever. And I believe, more cities and areas are building recycled water infrastructure so that people can now or will be able to use recycled water in the future for irrigation, especially like apartment buildings, things like, and bigger developments, and more places are requiring that those larger developments have separate purple piping in the ground for future recycled water use as it becomes available. But yeah, that's different than like on-site greywater treatment systems or rainwater. Of course, a golf course could implement a greywater system from the clubhouse, but they wouldn't be able to produce enough water to be really meaningful for the amount of water that they use.
Awesome. And that's one of the things that the Greywater Project advocates for, to have greywater ready pipelines in new constructions and in large buildings and facilities like that. And I think I could probably take the final question from Holly about mulch basins with regards to whether having a mulch basin around a poplar tree would be helpful for her greywater irrigation. And I would say probably yes, because it would allow the greywater to soak in better, and that can be beneficial in terms of like maintaining the health of your poplar, and in terms of greywater irrigation as well. So I would say go for it. That sounds, a mulch basin in that case sounds like it would be a good way to go. Yeah. All right, thank you everyone for all the questions, and also thank you to everyone who continued to stay after to listen to the answers. Before before people drop off, I just want to thank our speaker Dakotah once again for taking time out of his schedule to give us this presentation and explain some of the work that he is really, really familiar with in terms of rainwater and greywater systems. And one more time, I just wanted to plug the Greywater Project's programs. You can always learn more about programs like the art competition, the curriculum, and policy advocacy group on our website, which is thegreywaterproject.org. That's gray with an E. And you can reach out to me with any particular questions you might have about those programs, or other ones that are on there, such as the water challenges. So thank you all so much for coming, and we hope you stay in touch with the Greywater Project moving forward. Thank you.
Thank you.
Thanks.